Standing 25 stories high and weighing 100,000 tons, this isn't just a ship, it's a floating fortress. This is the Ford-class Supercarrier, the most advanced and expensive warship ever built, with a price tag of over $13 billion. But before this nuclear titan can project power across the globe, it must face its first, most nerve-wracking mission, escaping the concrete womb where it was born. This isn't as simple as sliding a boat into the water. We're talking about a high-stakes industrial ballet, gently coaxing billions of dollars of sensitive technology from solid ground into the ocean that a single mistake during undocking could cause catastrophic damage. Holding this $13 billion asset hostage on land, it all happens at Newport News Shipbuilding, the only place in America capable of birthing such a monster. This is a story of how engineers use over 100 million gallons of water to wake a giant. Have you ever wondered how a massive aircraft carrier built entirely on land first touches water? It's not as simple as just pushing it in. The process of flooding dry Dock 12 is one of the most deceptively dangerous phases of the entire build. It all starts when massive sluice gates are open, allowing the James River to pour into the basin. We're not talking about a quick splash. This is a slow, controlled deluge that takes over 100 million gallons of water just to fill the dock to river level. The whole process spans multiple tides in several hours. Why so slow? Because rushing the water could create powerful, turbulent currents that might slam the 90,000-ton hull against the thick concrete walls, causing catastrophic damage before it even sets sail. As the water level steadily rises, the engineering team is essentially fighting a battle against gravity, using Archimedes' principle. For the carrier to float, it has to displace an amount of water equal to its own weight. At this point in the construction, the ship weighs about 80,000 tons. It hasn't been fully loaded. If the ship lifts unevenly, the immense stress could compromise the structural integrity of the keel itself. There's another, even scarier risk. Sometimes, the massive hull can literally get stuck to the timber blocks it rests on due to suction or friction. To help prevent this potential disaster, teams of highly specialized divers are actually in the freezing, murky water right underneath the Leviathan as it begins to lift. Their job is to inspect the hull in real time, swimming in near-zero visibility to ensure that no blocks are stuck to the bottom, and that the entire ship is rising perfectly straight. It's an incredibly dangerous task, but absolutely vital. Only when the divers swim back to the surface and give the all-clear signal does the ship officially transition from being a static building on land to a true vessel of the sea floating on its own for the very first time. You think floating a massive aircraft carrier is a hard part? Think again. The real nightmare is just beginning. At this stage, the brand new USS Gerald R. Ford is what they call a dead ship. Its huge rudders are locked, its propellers are completely still, and its powerful nuclear heart is silent. IT can't move or steer on its own at all. It's basically a 100,000-ton paperweight floating in the water. So, how do you move a floating skyscraper out of its dry dock? You call on the unsung heroes of the shipyard, a fleet of humble tugboats. This isn't about speed. It's a high-stakes game of pure precision. The space between the carrier's giant flight deck and the shipyard cranes overhead is incredibly tight. Same goes for the gap between the hull and the dock walls. We're talking clearances measured in feet, sometimes even inches. Imagine a mistake like that could cause millions of dollars in damage in a matter of seconds. It's a terrifying thought, and why every single move has to be perfect. Orchestrating this controlled chaos is a dock master. They are the conductor of this massive steel orchestra. Perched high above, they radio commands to each tugboat captain, coordinating every push and pull to inch the carrier backward. The pace is painfully slow, sometimes less than a few feet per minute. The physics at play here are just mind-boggling. Once 100,000 tons of steel starts moving, it really doesn't want to stop. The tugboats have to work in a perfectly synchronized dance. Some push, some pull, all constantly fighting against the river's current and the unpredictable wind. They guide the colossal vessel stern first out into the open water. There's no room for error. This isn't just towing. It's arguably the most delicate, high-stakes towing operation on the entire planet. The skill and coordination required are simply incredible to witness. As the sun sets, tugboats guide the massive carrier to the outfitting pier. This isn't the end of its journey. It's just the beginning of the next phase. The basic structure is complete, but now the real work starts. This is the fitting out stage. Over the coming months, shipbuilders will install and connect miles of fiber optic cables, bring complex combat systems online, and even fuel and test the nuclear reactors. After that, it's time for sea trials. Imagine this giant vessel, essentially a floating skyscraper, being pushed to its absolute limits. The Navy will perform high-speed maneuvers and sharp turns, almost like drifting a city block, to test the hull's integrity. Seeing its silhouette against the sky, you can't help but feel the sheer scale of American industrial power. The rollout of a Ford-class carrier isn't just about steel. It's a powerful statement that controlling the seas remains the ultimate projection of global strength.